What's the meaning of differentiation? Differentiation is a fundamental concept in calculus. This means it is one of the most important basic foundations that we must learn and understand in this subject. The main core of differentiation is dealing with the rate at which a quantity changes. It helps us observe and calculate how much one value reacts when another value changes. Technically, differentiation is the process of finding the derivative of a function. When we perform this calculation and find the derivative, it provides us with a very useful information about the slope of the function at any given point. So, by using this method, we can easily know the exact gradient at any specific position on the line. Moving on the core rule. To solve differentiation problems, we must master these 5 basic techniques. First, the power rule, where we bring the exponent to the front and reduce the power by 1. Second, the constant rule. The derivative of a constant is always 0. Then, we have the product rule. Apply when 2 functions are multiplied. Next, the quotient rule. Apply when one function is divided by another one. And the chain rule. Used when a function is nested inside another function. Next, we look at specific type of function. The trigonometric rules help us differentiate functions like sine, cosine, and tangent. We also have the generalized power rule, which extends the basic power rule when our base itself is complete function. Lastly, we use specific rule for exponential function, which frequently appear in our syllabus. Now, let's look at a very special and important technique, implicit differentiation. We use this method when equations mix x and y together in a way that makes it difficult to solve for y explicitly. The golden rule here is to differentiate every term on both sides with respect to x.
Hi everyone, my name is Hamizah Hanani from class JCS1432D. So this video is about me going to explain to you guys about questions 2D, which is y is equal to e to the power of negative 2x over 1 plus 3x squared. So let's check out.
To differentiate the function, I noticed the function is expressed as a question. So I will use the question rules. We let u is equal to e power negative 2x and v is equal to 1 plus 3x squared. To differentiate u, I apply the chain rule. After differentiating both u and v, we substitute this value into the quotient rules. Since e power e2x is a common factor in both terms of the numerator, so we factor it out. Now, expand the bracket and rearranging the term give us this. After that, I factor out the common factor negative 2, therefore the derivative of the function is like this.
Okay, next question 2k. Given y equals to ln 3x plus 2 times x cubed. First thing first, we have to label it as u and v. Second, we have to use product rule, which is dy dx equals to uv prime plus vu prime. Now we just label it u and v, right? So we have to find u prime and v prime. So the answer for u prime is 3 over 3x plus 2. And the answer for v prime is 3x squared secant squared x cubed. Next, using the same formula, which is product rule, dy dx uv prime plus vu prime, we have to replace it with the answer that we got. So we replace it and it becomes ln 3x plus 2 bracket 3x squared secant squared x cubed plus time x cubed bracket 3 over 3x plus 2. So we have to solve it, and the final answer is dy dx equals to 3x squared ln 3x plus 2 secant squared x cubed plus 3 times x cubed over 3x plus 2. That's all for question 2k.
Hi guys, me again. I'm going to explain you guys about question 3. F line 2xy minus cos x plus y equal to 6x minus 3.
For this equation, our objective is to find dy dx. First, I differentiate every term in the equation with respect to x. To differentiate ln 2xy, I apply the chain rule. Next, I differentiate 2xy using product rule. 1 over 2xy, 2y plus 2x dy dx. We simplify the equations and separate the fraction into two parts, which simplify to 1 over x plus 1 over y dy dx. Next, to differentiate cos x plus y, we are using the chain rule. The two negative signs cancel, giving sin x plus y 1 plus dy dx. After we expand, we get sin x plus y plus sin x plus y dy dx. Differentiate the right side. Derivative of 6x is 6. The derivative of a constant is 0. Next, substituting our result into the differentiate equation gives group all terms containing dy dx on the left side and factor out dy dx. Finally, I divide both sides by 1 over y plus sin x plus y to make dy dx the subject. Multiply the numerator and denominator by xy to remove the fractions. Therefore, we get our final answer.
In this question, we are required to use the linear approximation method to estimate the value. First, let fx equal set 5x squared minus 1. Since 1.04 is close to 1, so x naught is equal to 1 as the point of approximation. Next, I calculate the change in Sx. Sx equals to 1.04 minus 1. So, Sx equals to 0.04. Then, I find the derivative of the function. I rewrite the square root as a power fx equals 5x squared minus 1 to the power 1 over 2. Using the chain rule, f prime x equals 1 over 2 times 5x squared minus 1 to the power minus 1 over 2 times 10x, which simplify to f prime equals to 5x over 5x squared minus 1. Now, I apply the linear approximation formula. I substitute x naught to 1 and ss to 0.04. I evaluating the term f1 equals 2 and f prime 1 equal to 2.5. Therefore, f1.04 equals to 2 plus 2.5 times 0.04 equals to 2 plus 0.1 equals to 2.1. Hence, the estimate value of set 5 times 1.04 square minus 1 using linear approximation is 2.1000. Correct to 4 decimal places. Thank you.